Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Good night, everyone. We are proudly present our research under the title Mathematical Ability of Bugis Community in the Lipa SabbE of Sengkang in the International Conference on Mathematics on Learning Research. The authors consist of four authors. The first is Sulfikar Busra, it's me, and the second Andi Aras, the third Buhaira, and the last Hikmawati Fatuli. We are hoping that you can follow our presentation tonight. The first in this presentation there is introduction. In the introduction, I want to explain about the basic idea of ethnomathematics. The next, Lipa SabbE of Bugis cultural heritage, and the third, ethnomathematics of Bugis. The fourth, integration between mathematics and local culture of Lipa SabbE. And the last, about several topics that become basic studies and must be programmed for all mathematics students, such as sequence, algebra, and geometry. Talk about basic idea of mathematics. We want to find the Ubiratan de Ambrosio. Yes, we can meet the Ubiratan de Ambrosio, well known as introducer of the terminology of the ethnomathematics. In 1985, De Ambrosio introducing mathematics as a ethnomathematics as a mathematical study of plants from deepening activities in a culture group that can be identified so that mathematical thinking patterns can be found in it. Furthermore, De Ambrosio have many research, many studies about the ethnomathematics. The other researcher is Rosa and Ore in 2011. In Rosa Ore study about the ethnomathematics, they gave the result that the mathematical approach in the mathematics curriculum is very meaningful and relevant in improving the quality of students in the field of education. Indeed, it was revealed that the application of mathematics in the mathematics curriculum helps students' intellectual, social, emotional abilities for the distinctive culture that exists in their environment. Moreover, in Rosa and Ore studies, the main point is what the relationship about the ethnomathematics and with the students' ability in mathematics learning. From the two studies, from the Ambrosio and Rosa Ore, have initiated various studies related to the integration of science between mathematics and the study of the local culture. The study from the Ambrosio and Rosa and Ore contributed to develop mathematics learning and directly relate with our research. And the second, I want to talk about Lipa SabbE as a Bugis cultural heritage. We know that Lipa SabbE is a local culture in South Sulawesi, exactly in Sengkang city. One of the cultural products that can be the object of study in mathematical exploration is the silk serum in the Bugis Comunity. This silk serum is commonly known as Lipa SabbE. We can see the image, the site from this text. There is many Lipa SabbE or Bugis silk with the various motifs. Apart from the Bugis cultural heritage, which has a symbolic meaning and philosophy of cultural values, Lipa SabbE also reflects a system of knowledge, skills, and attitudes. This statement we citate from the Sulfina Jayanti. In the historical of Lipa SabbE, actually, the craft of weaving silk is an activity that has been passed down from generation to generation since 1014. The introduction for the third is about several previous studies that have attempted to identify mathematical concepts in various kinds of batik ornament. We know that the batik ornament is one of many kinds local culture in Indonesia. Fausia in 2021 explored solo batik with the count type as a cultural product in finding the application of the geometry transformation. Brahmana with the Ambrosio in 2020, in 2020, identify the geometry transformation in Semen Rama batik and Sidoarjo Wahyu Temurun batik. They also explore the concept of geometric transformation. Several previous as a mathematical that has related with the Bugis local culture. There are many research. There were many research. The first, Pathoudin et al. Explored mathematical concept in barong pocek. We know the barong pocek is one the traditional food from South Sulawesi. And we know that the biggest site in South Sulawesi is Bugis. The second studies that have been explored about the ethnomathematical from Busra and Pathoudin. This research find the volume model of a rotary object on Bugis traditional food. So that in this research make a new focus, namely in this research focused as the mathematical research that aims to explore the mathematical abilities of the Bugis people in region of the Lipa SabbE. Why we choose the Lipa SabbE? Because there are many aspects in Lipa SabbE, mathematical aspect in Lipa SabbE. We can find it. So that in this research actually focus in mathematical ability in Bugis community in designing Lipa SabbE motif. Talk about mathematical research. Actually, there are two the goal orientations. The first goal is oriented to the science of mathematics, namely to enforce the creation of new knowledge with it is hope that it can spread under the perspective that there are various mathematical activities that develop in a cultural group. It means that with the mathematical research, we can find the new knowledge in the community, the knowledge we can use in the formal education. In the second is oriented towards mathematics education. And the first, we know that about the science of mathematics, and the second towards in mathematics education. It means that in this case, as mathematical research seeks to uncover mathematical concepts that develop in society and integrate them in formal mathematics learning in schools, like in elementary school with the traditional games, with the traditional foods, maybe in the senior high school, junior high school, in mathematics learning, we can integrate the research. We not only integrate, but we can find how effective and how efficient the mathematical topic to build up a student in school. In general, mathematical activities that can be found in cultural communities include counting, blessing, measuring, designing, playing, and explaining. This let's say the aspect in mathematical activity from this shop in 1991. The second activity we will explore in weaving process Lipa SabbE in Sengkang. All right. After introduction, I want to explain about methods. The first, the types of research. In this research, applies a descriptive qualitative research with the ethnographic approach. And the second about object of research, the main object in this research is silk fabric motifs, which are directly obtained at the location of craftsmen in Sengkang City. Let's talk about data collection technique. In this research applies three data collection technique. They were is observation, interviews, and documentation. We can see the activity data collection technique in the some image in this slide. Next, in the object of research, actually there are two. The first is about weaving process. If we want to know the weaving process, we have to know equipment and material. In the weaving process, in this research, we find some mathematical concepts and mathematical activity, like in this hop 1991. The second object is motif of Lipa SabbE. From the motif of Lipa SabbE, we will explore about the geometric transformation, number patterns, algebraic representation, and smoothing technique with the calculus technique. Talk about steps of this research. We adapted step of research from the James Bradley. There are five the main stage. The first is determining the scope of this research. To determine scope in this research, actually talk about object, location, informant. I have explained about object in the before the previous slide. It was weaving process and motif, and the second determine the location. In this research, we take two villages. They were Kelurahan Padelo and the second Pakana village Sengkang. And then about informant, we choose 4 informants, one for key informants, and second for the primary informant, and 2 informants for supporting informant. And the second stage about data collection. We collect data after determine the scope of this research. In data collection, we use 3 techniques, and I have explained about it. The first is observation, and the second interview with informants. In this process, interview with informants, we conducted the ethnographic record, and then documentation with the recording audio and recording visual. In the third, the state of ethnography from the James Bradley is domain analysis. In domain analysis, we make a focus observation, and the second, we selected or reducing data observation. So not all from the data we use in this research. So there are data proposed. So we selected or reducing data processing. And the fourth, taxonomy analysis. The taxonomy analysis consists of mathematical concepts in process matching up with the mathematical concept was matched with the weighting process and mathematical concept that match with emotive Lipa SabbE. And the last is writing ethnography. We can see that mind mapping but the type of taxonomy analysis. We know that in ethnomathematics integrate about ethno and mathematics learning. In ethno-linguistic research, we choose the Lipa SabbE, and then in mathematics aspect, we choose formal knowledge about number pattern, geometry, algebra, and calculus. In the Lipa SabbE, in waving technique, we observe the process, so we can find counting process, designing process, and measuring process. Specifically in designing and location decorative motifs, we will find about size, direction, graphics, and shapes. And for geometry, algebra, and calculus, we will explore about the geometric transformation, and we explore the algebraic representations and the concept of calculus with the polygon technique. From the background or introduction and method, we get a new information, a new finding about mathematical in Lipa SabbE from Sengkang. The first is talk about equipment and materials. In the weaving process, as for the STBM, it is composed of several elements that have different functions, including piston, pedal, waterhagen, styrofoam, aweren, boko-boko, suhu, jaka, pabisan are, tali, boom, dinamo, pedal. The all equipments have different functions. We can see the image from some equipment in STBM. Oh yeah, STBM is alat tenung bukan mesin. The mechanic of weaving, non-machine. For the function of every single every single equipment, we can see the every single equipment like a pesa. Pesa is waiting to the form of a small board that lets to roll the basic yarn. The second, there's Walida. Walida is a part of ICBM, a special stick used to tighten the bottom strip. And third, there is Styrofoam or saddle. Styrofoam or saddle like this, we can see like this, which is used to insert web yarn that moves back and forth, and we can see extension in this picture. This is header, and then this reed, and shuttle like this, and this shuttle. This shuttle move from left to the right, right to the left, bringing yarn. Next, there's what again? Cloth roll like this, cloth roll, and cloth with the cloth produce. We can roll the cloth at times. And the 5 aware, the 6 boko-boko, and rounds of book, and the 8 comes, the 9 pabicang are, the 10 root hanger, and the last jakatoron or jakagenma. Next, about some material, the first work thread. What is the third thread, which is the basic thread of the Lipa SabbE. We can see in the image the work thread in this black thread, but in some STBN there is many color, variety of color that are arranged in such a way. In Geoga, the work thread is the basic thread that is stretches in the direction of the craftsman. If we see in this picture, you can see the mini chair. So the craftsman stay here, sit here, and we can see the work thread stretches in the direction of the craftsman. And the second material is web yarn. Web yarn. This is the different yarn from the work thread, which is also used as the base is threaded perpendicular to the work thread in the process of inserting the web into work yarn using a cylindrical coil container known as a saddle. And the third motif thread, a motif yarn, we can say like this, and the silver color and the green color. This is the motif thread. The motif thread we insert in the above from work thread and web yarn. All right. The next explanation about process. The first process we can find about menghani. menghani is some Bugis terminology in process in waving process. It means the process of making strands of thread to become warp thread. And the second, placing the warp thread into the boom contained in the ATBM. The third, inserting the warp thread in the eye of the cam. We can see in the picture there is the cam. In this cam, we inserting the warp thread as a base material. The fourth, equalizing the tension of the warp thread like this. In this how to say, in this warp thread have to be the tension of the warp thread. The five about the silent content and method. The process of weaving using a TDM should begin with adjusting the position of the gun and stamping. After that, start inserting the wrap thread into the needle side. And the second, in making certain motifs, craftsmen need to adjust the position of the pabichang are. Pabichang are is tools for counting yarn. And so pabichang are, the craftsman can mark the motif thread on the styrofoam inserted to the side position. All right. The discussion about mathematical concepts in the weaving process in Lipa SabbE. In this research, there are five mathematical concepts. They are matrix concepts and geometric transformation in the motif, and the third number pattern and the design, and about algebra representation. The next about the calculus concepts. We back in the matrix concepts in weaving process. In this research, we obtained that weaving process we can find the matrix concepts in the arrange of the warp yarn and the weft yarn. Like this, the warp yarn are inserted into the needle and cross vertically. The yarn vertically, then cross with the weft horizontally. So there's the warp vertically, and horizontally with the weft yarn. The arrangement of the warp yarn in the eye of the boom consists of two arrangements. Namely, the upper, we can see this picture in figure 7. Namely, like this, in the black color is the upper warp yarn, and the gray colors lower warp yarn, and the blue is weft yarn. We can see that the warp yarns is vertically, and the weft is horizontally positioned from the craftsman. From the upper warp yarns, lower warp yarns, weft yarn, Make the perpendicular position of the warp and wave yarn results in a very tight arrangement of rows and columns. Mathematically, the interlacement of the warp and wave yarn is in accordance with the matrix concepts. I mean like this. Would say the uh, cross from the warp yarns, lower warp yarns, perpendicularly uh, result the matrix concepts. In the welding process, the matrix concept aim to the craftsman in counting process to make a motif from the Lipa SabbE. About the counting in Bugis Comunity, well known as a technique of feedback. Yan counting technique in making motif. This counting activity is in the form of placing certain motif threads into the warp or basic threads. I mean that if the craftsman or weavers make a motif, she has to count the pabicang are and give the marker. So he can make a new motif easily. And second, the mosquito technique is also used in the SabbE technique. And in the SabbE technique, I mean that the craftsman use their hand directly. Not use styrofoam or shuttle. Like this in the under figure, you can see from to the every motif use the what's that shuttle or styrofoam. And this process with the manually or use the SabbE technique for the small motif. And the next the other mathematical concepts on Lipa SabbE motif before the last explanation talk about weaving process. In this section, we will talk about the mathematical concepts on the Lipa SabbE motif. The first about geometric transformation. Geometric transformation is one part of geometry which refers to change in the location, size, direction of geometry objects such as points, polylines, or polygons. Geometric transformation we can find in the some motifs in Lipa SabbE like this in 16, the concept of reflection. We can see the motif is symmetrically. And then in figure 17, vertical reflection. Vertical reflection on the sandstone motif. We can see the X, the axis X, like mirror from the object above from the X axis. And then in figure 18, we can see the concept of translation. translation. Translation about a movement from the object without size change, because of size. The next, in figure 19, the concept of reflection and translation. So the one geometry operator use two operator, namely reflection and translation. And the figure 20, we can see there is how to say, layang-layang belah ketupat. There's the big size and same ratio. So there is the small with the similar shape. We know that dilatation concept. The concept of reflection, translation, dilatation, rotation, and translation has also been explored in solo batik by Faizia in 2021, in last year, and in Trasmi Cirebon by Karima et al. In 2030. The second mathematical concept in Lipa SabbE motif about number pattern. With the number pattern, to know the number pattern in Lipa SabbE motif, we can find some number pattern, not only number pattern like arithmetica or geometric, but we can see like this because in the motif, in this the nature motif, and this redesign motif in with the Microsoft Office Excel. For making in redesign motifs, we can count how many motifs in the Lipa SabbE. We insert it in the Microsoft Office Excel, and we can find the result of number pattern horizontally of the putuk motif. This is the putuk motif, like this, 0, 0, and in the end with the 0, and the third, and with the fourth, we can see the 15, and from the 15 increasing from the 0 to 15, increase of 15 different is 15, and for the for term from the 15 to the 29 has a different 14, and the last from the 29 to the 42 it was increased in 12. So this is 15, this 15, 14, and 13, and the last is 12. And we can see that this is decrease from the 54 to the 42. We have the different is 12, and the last difference is 13, and the last 14, and the last 19. But the half decrease in the last term. And then the result of the identification of the number patterns practically on the future motif like this. We count with the Excel. We find two in 12 times and 6 in 30 times, like this. This is the short. This is the yes. Oh, I'm sorry. Vertically. Vertically like this. This is 2. This is 2. And then we have 12 times, and 6. This is the 6 columns, and in 15 lines. 15 column and line. And the next, there is 10 more, less than yarn. I mean 10 column, and in 14 times. And the next 14 like this. That's 14 columns in 15 times. So we can see that how to say, increasing from the how many times the type of columns in this motif. The next, the other motif is close velocity motif. Before we can see the pucuk motif in the velocity motif like this. Close velocity motif is very full for every single yarns like this. Outside of the small motifs with the technique SabbE. We can find the number pattern like this, from the 0 to 5, from the 5 to 9, from the 9 to 13. So we can put 5, increase 5, increase it in 4, increase it in and 4, and increasing 4, 4, and 4 again, and 4 again. After this, this is the pattern. We can see that this increase for every every kinds of for term. The second term is the third term. The fourth term is 4 times, and like this is 4 times, and 9 in 16 4 times, and 17 4 times. This back decrease. Decrease is different with 4 from the 13 to the 5 and go on. The last in the 0. This is the symmetrically motif. we can make the number patterns like this. So from the motif, we can find that the Bugis community, especially the craftsmen of wafer, have this uniquely mathematical ability like this. Modified Walasugi one, so you can see that before Walasugi motif with the close Walasugi motif, and in modified like this, you can find the number pattern like this, and the last the modified motif Walasugi like this. The all motif in this research we choose the symmetrically symmetrical motifs. In the third mathematical concept about algebra representation, the first we use the motif of balotetton. The balotetton motif is assigned from the pattern of lines of a certain thickness that are perpendicular to the plane one straight. Thus, the lines stand vertically to the mouth of the parent. Like this, we can see there is a line like this, a motif. In this motif, a certain thickness that are perpendicular to the plane of a tree. The next, the algebra representation of balotetton like this is xe in constant number. Actually, it's not yet to mention as a function. This is not function because this is vertical and not suitable with the function criteria. And the second, Makaluk motif. Makaluk motif like this. The motif of Chinese from the combination of how to say the position of Wat Yang and West Yang. In algebra representation, we can see this the constant functions. And the next, the several motifs, we can find the linear equation model like this in figure 28 and figure number 27. This is we can find in this motif from the cell motif or oblique motif. In the Bugis community, it's well known as cell motif. From the algebra representation, the first function is the linear with the gradient 1.3 and constant terms 7.25, and the other line has a similar gradient, namely 1.3. And the next, we can also find polynomial in the Pucuk motif. In the Pucuk motif like this, with the GeoGebra, we can find the polynomials like this. Now about the actually different with the polynomial and the digit motif. This is use the concept of Riemann sum. If we no. I mean if we see the motif of Fuji motif, we can approach the shape with the concept of Riemann sum. And the first about the Riemann sum and trapezoidal sum concept. And like this, the trapezoidal sum, and this is we use the Riemann sum or lower sum and upper sums in GeoGebra. The last mathematical concept is the motif of Lipa SabbE. In this type of Lipa SabbE is Lagossi. Some Lagossi motifs are visualized as flowers like this figure, geometrically, it can be said that the Lagossi motif is various colors or asymmetrical. These figures, like the leaf of flowers, make become a plane curve, the plane curve. But that on the concept of calculus technique, informant use the rectangular sets are arranged and form polygons with curved borders. I mean that the motif of the young motif have the young motif similar with the rectangular, but the wafers or craftsmen arrange this so it seems a flowers. So based on the concept of calculus, this technique can be found in the technique of calculating the area of a curve, area which is approximated by the area of a rectangle. As introduced more than 1,000 years ago by Archimedes. You can find in the Fairback et al. In calculus book. Calculus book, the first edition. I mean the part 1. This shows the skill and intelligence of the craftsman in making Lagossi motifs from a collection of rectangular segments into curved areas that represents stalks, leaves, and flowers like this. The stalks, leaves, and flowers. The last, what the contribution of research in the development of mathematical learning? The results can be a relevant learning resource for students in the field of mathematics of various levels by utilizing the attributes of local wisdom. Number 1, we based on the research and discussion. Number pattern problems in mathematics learning are usually in the form of continuing the sequence of numbers after the last term based on a certain pattern found in the first term, like in the in problem in test CPNS, number pattern problems like this. We just continue the number in the last term. But according the research, the pattern can be in arithmetic sequence, geometric sequence, or both. Through this research, identification of number patterns can be developed through figures on Lipa SabbE motifs, especially in the symmetrical motifs. And the second about the geometry and algebra learning. can also take advantage of the motifs found on carrots by this research. Geometry and algebra studies in this research include transformation geometry, like line equation, like line modeling, and polynomial modeling through interpolation techniques. About the learning calculus, especially in learning integral equation, the Catman ability to make curve plans such as Lagossi or flower motifs is approximated by the arrangement of the combination of web, warp, and motif grid. I mean, in the formal class, the concept from craftsmen to make legacy motifs or flower motifs, it can be used in to understand the how the rectangular approach the curve area like this. As a conclusion, there are 5 conclusions. The first, the process of differential fabrics of the Lipa SabbE type shows the existence of various ideas, creativity, methods, techniques, and mathematical practice by self-craftsmen in the city of Sengkang. And the second, the wafer have numeracy skills, so the technique or accounting technique in determining the index or position of making motifs. And the third, the craftsmen also have the mathematical ability to produce certain number patterns to maintain the balance of the motifs so that they remain symmetrical and still maintain their aesthetic elements and method of union either throughout the textile technique or how the software technique. It means that the craftsman or the wafer have the unique mathematical ability to make a number pattern. Therefore, wafers also have the ability to approximate curve plans in the form of chords or polygons through rectangular yarn segments by the curve and rectangular pattern. And the last, some Lipa SabbE motifs can be modeled into the constant function, linear function, and digit polynomial function. Just like this, our presentation. I believe there are many weakness in our research or our way to present our research, but we confuse, we are aware that this is the learning process. So we will make we hope better in the next days. For the last acknowledgements, the appreciation to the party involved for the moral and material support from Ministry of Religion and the Republic of Indonesia, which had launched this program for lecturers, which was followed by the provision of research funding assistance. Second, I do appreciate to LC 2M of IAIN Parepare who have supported us in our research administration efforts. We also extend our deep gratitude to the head of the Campus Mathematics Study Program at IAIN Parepare who has supported and provided technical direction related to the implementation of the research. In this research, used some reference put 20 just 20 reference. Thank you for everyone have listened and for pay attention with our presentations tonight. Wassalamualaikum warahmatullahi wabarakatuh.